Hey guys, and welcome to Functional Print Friday, and welcome back to the shop. So we're over here on the other side of my shop today because I would like to figure out dust collection for this bench grinder. So a couple of years ago, I tried to move everything that makes general dust and mess into this one area of my shop over here. And that's the router table, the spindle sander, the bandsaw, and the chop saw that you see that's actually accessed from the other side over here. And the dust gets picked up by this dust collector that we see down here on the floor, and it wires off to the bandsaw or this hose that comes up here that goes into this box behind my chop saw that is normally closed. So the only air that's actually coming in is what gets sucked in through this pipe here. And if I'm using the chop saw, that gets connected to up here, and this lid comes off down in here to just generally suck all the dust from this whole area that the chop saw makes when you run it. Or I can take this, leave the cover in here, and connect this to the side of my belt sander here. I can connect it to this port over here for the disc on the side, or I can connect this to the spindle sander over here. And it does a decent job for all those. So there's a number of things we're going to have to figure out for this project to be successful. First of all, we have got to get away from this reduced coupling for this connection. We need to move at least as much air as we're going to get through the larger part of this hose for sort of like a curtain of air to work, or a curtain of suction in front of this guy to work. So we're going to have to get rid of this piece in here, which I think is probably going to prompt me to design a better connection system for all these tools, because if I have to swap the piece in the end of this tube, I'm just not going to do it. You know how it goes. You got to grind something for 30 seconds. You got to make one cut on the chop saw, or you got to use the spindle sander for 2 seconds. The last thing you want to do is, change a bunch of fittings out to collect dust on that. So I might actually come up with like sort of a magnetically latching system that allows us to use the full size of this and just connects it to all these different tools. But that's not going to be today's project. That's probably going to be next week's project. So let's assume we've solved that and we're able to connect a hose that is this size to some sort of box that we make for over here. What I'm thinking right now is a similar approach to what I did for the chop saw, where there is just a large intake in the back that is rectangular that just sucks in all of the air from the surrounding area and draws it down in there. And I think we're going to have to keep it pretty thin because we don't have as much air volume to work with as we do over here, but I don't think we need it. I mean, the chop saw throws stuff everywhere. This isn't that bad. It doesn't throw it just right by the wheel. It tends to throw it, I've found, in the area around the wheel, a little bit to the left, a little bit to the right, and then just sort of up in the air a little bit. It sort of circulates and floats around with the disturbance in the air from the wheels moving. So that's what I'm thinking that we want to do here, is model a box that'll mount on the front face, maybe offer the ability to select which wheel that we're using, because this is a pretty good size. I think this is, grab the tape measure. Yeah, this probably needs to be about 400 millimeters in width, which is even bigger than I was thinking. So we're definitely printing this on the Neptune 4 Max. That machine will do 420 by 420. If we do 400, that'll still leave us some room to work with on that machine. And probably go roughly the height of the board here, and maybe accounting for these two pieces up here that this stuff mounts on. Because I want the dust collection to be even between the two wheels. If we just have a big box with sort of a thin slot in the top and connect the dust collector to the side, the majority of the air is going to come from this side. And even if we block off that part, I don't think we're going to have as efficient air routing on this side. So what I'm thinking is the dust pickup is in the center, dropped down in the box. So maybe this connects to the side, and then internally it routes over to the center, comes up, and then comes up at an angle up to either side, just so that we have the maximum efficiency of drawing that air into the box. Again, just creating sort of this air current that comes down across the front of this, comes down from in front of it, and just draws it down into that box and then into the dust collection system. So maybe we have like a piece on the top that maybe slides back and forth, or maybe something that flips back and forth, so that we have just an open rectangular slot in front of whichever grinding wheel we're using. All right, I've got to take a bunch of measurements here because I want this to be as low profile as possible. So I want to get this thickness here the distance from this front face to this face, and then the height of this face so that this box ends up just fitting snugly right up into this space. So I'm going to do that. I'll draw that first, and then we'll design the box to fit all those faces. So I'm going to get started, and I'll bring you back. All right, guys, and here is the design that I came up with for this. And I spent quite a bit of time drawing this. I changed my mind numerous times in the design process with just how I wanted to shape the inside of this to maximize the efficiency of the airflow. And I'm happy with the result. I will say I broke away from the normal methodology that I use for designing something like this. If this was smaller, I would have absolutely not gone this far before running a test print and just seeing how everything was going to fit. But because this object is just so large and I know it's going to take several days to print, I tried to get to a final design on V1. So I guess we'll see how that goes when I finally print this thing out. And I haven't sliced it yet. I don't know how much filament it's going to take. I mean, this thing might be more than even a single roll of filament to get it done. All right, let's take a deeper look. So starting at the top of the box here, this slat or piece here at the top is designed to slide back and forth and control which side of the box we're sucking air into. Because I think the opening is just going to be too large for the size of the hose that we're running up to this. So the idea is if we're grinding on this side, we have it slid over to this side. If we're grinding on this side, we slide this over. And I tried to design this that I can just very quickly drop my index finger into it and slide it from side to side. It's just gravity holding it in place there, sitting on that thin 2mm rail that runs around the full perimeter of the top of the box. If I hide that and we look down into the box, you can see that it slopes from either side. The idea being to sort of help guide the air into the shape that it needs to be to drop into the lower part of this box. But also if any bits of dust or anything drop into here, that a combination of the airflow and gravity should cause them to work their way along that and then just drop into this bottom part where it's going to get sucked out of the box. So I think the easiest way to understand what's going on inside here is if I just whack one of these walls off there. I mean, that gives us a much better idea of what I'm trying to do with the airflow, because we need to shape that airflow from this, sort of wide curtain of air. Even with the, even blocking half this off, we still have a very narrow, wide curtain of air that we need to drop into here, fit through this rectangle at the bottom, and then it needs to get sort of shaped again as it winds up coming out of our circular exit here on the side into that hose. So I really tried to just design everything in here in a way that we're going to have the least amount of resistance for that air changing direction and sort of changing shape in its flow. And you see, the way that I slope this and I have sort of a wedge over here also gave me room to put a screw hole in, because we've got to actually attach this thing to that front face underneath the grinder. And if I whack another face here, you can see what's going on. We have a pretty deep counterbore coming in, a flat bottom we can use a washer on, and then a much smaller hole that is roughly sized for just like an all-purpose or drywall screw to be able to slip through. So that should enable us to pretty easily just attach this to that front face with 2 screws. All right, I think the last thing to tackle is how we're actually going to print this, because there's no orientation that we can put this thing in where we don't end up with a bunch of supports. We've got this big sort of, chamber here at the bottom. I mean, we could print it on this face. That would leave most of this self-supporting on the inside, but we still have this back wall back here, and that would be a mighty tall print to have swinging around on the bed of really any printer. We might be able to do it, but I think what makes sense to do is probably just to print it on this face or this face and just deal with the fact that we're going to have supports inside. So let's open this in the slicer and see what we can do. All right, guys, this thing is massive. So this is the bed, the 400 by 400 millimeter bed on my Elegoo Neptune 4 Max, and I still ended up turning this guy 45 degrees just to have room to have plenty of brim on this to hopefully keep it from lifting off the bed. Now, from a supports perspective, I just turned on auto tree supports, and I'm actually pretty happy with what it's done. That might look like a jumbled mess in there, but I actually don't think that's going to be too hard to remove. So if we drop down through the layers here, you can see there, that gives us a better angle. There's not quite as many in there as it looks like there is from the side. And then when they get closer to the top, they really spread all out to support the roof of that chambered section at the bottom. And I don't think they're going to be too bad to remove. Maybe I'll eat my words, but it looks like they'll knock out of there pretty easily. We don't need supports anywhere else. I mean, we're probably not going to have perfect overhangs on our counter bores here for the screw holes, but that's just fine. So I think at this point, there's nothing left but to go ahead and hit print. But man, this is going to take a while. So the estimated print time here is 2 days, 2 hours, and 19 minutes. And take a look at the filament. This is going to take just shy of an entire kilogram roll of filament. This will be 965 and change grams of filament. And it's not like this is extremely dense. I mean, I did 3 outer walls on this because I do want it to be fairly strong. And I did gyroid infill at 15%, which is also, pretty low. Now, I mean, I don't think we're going to pick up any additional strength from doing a greater amount of infill. Really, I tend not to go below 15% just because when you get back up to your solid layers, if you have less than 15% infill, you really end up then needing to turn on more top layers until you get a smooth surface. So it kind of defeats the purpose. You may as well just do the slightly higher density infill and not run, an extra 2 or 3 top layers to get back to a smooth surface. So it's been a long time since I ran a print that was even going to take remotely as long as this one. So honestly, I'm a bit nervous, but let's hit the button and get to it. All right, guys, it is done. And yeah, I guess the supports weren't quite that easy to remove, but I ended up not rolling the camera because when I took this off the print bed, the first one that I grabbed just popped off so easy that I took just the handle from a hammer, jammed it down here a few times, everything broke loose, and I pretty much dumped it out just like that. And not only did this print finish without any issues, but I gotta say, it looks really good. I was worried about this. That was a rough 2 days of running down every few hours to keep an eye on this. But it came out really, really nice. This is by far the biggest thing I have ever 3D printed. I did a ton of work to tune that Neptune 4 Max when I initially got it. If you guys saw my video on figuring out that the bed on that printer needs to be heat soaked before you start a print, that was a huge game changer in being able to successfully get big prints like this from that printer. But the truth is, prior to this project, I really haven't used it that much because I didn't buy it just to have another printer to use. I bought it really for big prints like this. So it doesn't get used unless I have something really big to make. But here we are. All right, let's see how our top piece fits. I can tell you already that I wish I made this hole slightly larger. It's a little tight from my index finger. I tried to estimate it at my desk with the calipers, and it's slightly too small. It fits in there, but it catches. Here, I'll show you what I mean. So this fits in the top nicely, slides back and forth. My finger just kind of catches in there sometimes. Not always, but sometimes it just catches. I think I might actually go and adjust that to be maybe 2-3 millimeters larger and reprint this piece, because this is like a 30-minute print and I don't know, maybe 60 grams of filament. It's hardly anything. In fact, it's probably not even that much. This, on the other hand, was almost a full, it was just shy of 1 kilogram of filament to print this guy. So unless we discover something that is horribly wrong with this, I'm going to be trying to use this one and not reprint this. All right, let me figure out what length screws we need for this and the washers to be able to mount this guy. All right, the counter bore on our screw holes is super long here, so we shouldn't need anything longer than this, and it looks like these washers will fit all the way down in there. So let's go over and see how it fits. Huh. Well, we're flush with the bottom, but we've got a gap here at the top. All right, I figured out what's going on here. Let me show you the problem first. So there's about a 3 millimeter gap between the front face of this and the front edge of our table, or our top here. And I know I measured the depth from this face to this face like probably 3 times, but what I didn't realize is I was using the depth rod on my digital calipers, and there is a thin piece of Luan between the top of this piece of wood and these 2 pieces up here. That's the original top for this, and then I added these, and I totally forgot about that. So the depth rod on the digital caliper was going right into that gap and measuring the distance from the front face of that little spacer, or that original tabletop, to this. And this face here is about 3 millimeters further out. So I'm not going to reprint this. As I mentioned, this is like a whole roll of filament. So I'll probably end up making a spacer piece that just fills that gap so that doesn't just collect junk in there. But let's get this screwed into place and see how everything else lines up. All right, the fit of everything else is really good. This is flush down here. The step, the bottom face of this is right on the step of this piece, and the top face of this is flush with where we begin to slope up here on the dust collection box. We've just got that super annoying 3 millimeter gap back here that we're going to have to fill. I'll pop the sliding piece in here. I may end up making this slightly longer. Standing here looking at it, it just seems like the hole over here is wider than it needs to be. Not by a whole lot. I don't necessarily want to just center that gap in between the wheel. I want it bigger than that, maybe about that big. So I may run another one of these with that slightly larger finger hole and a little bit more length. Now, unfortunately, we can't actually get the hose connected to that yet. That's going to be part of another project, probably next week's video. But let's just sort of hold it up there, turn it on, and see how the airflow feels. All right, sorry, I know this light here is blocking your view, but it's also illuminating the into the box here. And I want to talk about the airflow a little bit. So with this guy over here, excellent airflow here. With this guy over here, even slightly better airflow over here. And I think that makes sense, because even with all the trouble I went through to design the smooth transitions down in this box and slope it down, if the air is coming in this side, it can just sort of drop down at an angle into that opening at the bottom and then exit from the side over here. When this is slid into this position, the air's got to come in and it's got to basically make a U-turn and exit the box. And again, even all the work I did to smooth out everything on the inside, I can still feel a difference. It's not a significant difference, but it will probably lead me to putting the carbide wheel, or the green wheel for doing carbide, on this side, because that's where my best airflow is. All right, guys, I think that is as far as we can take that for this week. I'm really happy with how everything fit up here, with the exception of that annoying 3mm gap. But next week, we are going to design a solution, I think a magnetic solution, that enables quickly switching our dust collection hose between any one of these items over here. So we'll have the full diameter of the hose, be able to quickly connect to our dust pickup box here for the grinder, but still be able to go into the smaller inlets on either side of the sander, the chop saw, or the spindle sander over here. Guys, as always, thanks for hanging out in the shop with me for this week's design and print. If you enjoyed this video, do me a favor, take a second, hit that like button. And if you want to check out more functional prints like this, we do a new video every single Friday. It's always a functional print. There's no multicolored garbage. So check out some of the other videos that I've published. And if you enjoy them, hit that subscribe button. And guys, if you do, I'll see you next Friday.